Hi, welcome back. Today we're going to talk about software architecture and project management. My goal from this lecture is that you understand the relationship between software architecture and project management. So we're going to try to answer two questions. The first one is, can software architecture be useful for managing projects? The second one, are there conflicts between software architecture and project management in general? We talked last time. I presented this slide several times now, and each time for specific purpose. And among the stakeholders that we can see here, we have the architect, and he has one question: what are the design constraints, and actually how can he or can they develop the architecture of the software? Before going further, I need here to stress the value of doing correct architecture for a software from the beginning. And I have a quote here. It is from Fred Brooks. Fred Brooks spends a lot of time at IBM managing projects, and he wrote his experience in the book Mythical Man Month. And he has here this statement at page 45. He says, "It is very humbling experience to make a multi-million dollar mistake, but it is also very memorable." So writing software is not to jump in to write code. It is about succeeding to deliver the customer requirement, to deliver software that satisfies the customer requirement. And the major problem, that major point of failure or major cause for failure for project is the architecture. And that is why I have this lecture. I think Fred Brooks already discusses a lot of issue that seems for novice that these architectural decisions that they are not problematic, but later on a project would fail, and this project they are multi-million dollar would fail. Based on my experience, I've seen a project that they 50% of the project, especially the one that are 1 year or more, 1 year or 5 years, they fail. They do not deliver because basically the architectural decision, they were not, some of the architectural decision, they were not correct or they were wrong. So let's start. The first one is first item that we want to get. What is a software architecture? And according to the IEEE, and here I refer to the IEEE standard 1471 of 2000, software architecture is the fundamental organization of a system, embodies its component, their relationship to each others, and the environment and the principles governing its design and evolution. So when we talk about software architecture, we talk about the organization of the software, of the system, and the component of this organization are the components of the software and of the architecture and the relationship between the software. But the architecture also includes the principles that govern the design of the evolution. What are the principles that the company uses? For example, the principles are use the simple solution, for example, or use, let's say, we want to have performance software, or we want to favor secure systems. So a different company might have different principles, and these principles need to be should be embedded in the architecture or considered in the architecture. So when we talk about what is architecture here, we said that we have two parts. One is the architecture defines the major component, and the second one, it defines the relationship between this component and the interaction. The architecture is the first design artifact where a system's quality attributes are addressed. So I'm going to come here to talk about the quality attributes. So, but it's the first time that we approach the solution of the system. So the architecture then represents the set of early design design that we do at the beginning, and it defines the rationale also behind the component and the structure. So when you make a decision and you choose a set of components, you choose a specific technology, you choose a specific tactics or strategy to address problem, then you have a rationale there, and that is part of the architecture. Simply because 1 year, let's say, after you develop the architecture, you might have a discussion, or some people might come to audit you, and those rationale, they will matter at that time because they were a decision, but there were reasons for those decisions, and the reason might change. And obviously, if the reason changed, then the decision should change or potentially could be different. So the first part of an architecture is there to satisfy a set of requirements. And those set of requirements, they come from the customer, obviously, and also potentially from the customer, or they come from the stakeholder, including the customer and the different other partners, stakeholders. So an architecture exists to build a system that satisfies requirements. If there is one, so we do not build system because we have fun with that, right? We can have fun with that, and that would be a requirement. An architecture is significant requirement or architectural driver here are the set of requirements that we would use to design the architecture. So we call them architecture significant requirement, or we call them architectural drivers. Architecture significant requirement imply a decision on how the component of a system must or should behave. So whenever we have an architecture significant requirement, either they are going to specify a set of functional requirement, and functional requirement here we can represent them usually in the form of a user story. As a user, I could submit an assignment, but also it might include constraints or requirement on how to do the functional requirement. For example, I can submit my assignment in 1 minute. So we put here constraints on the submission, which is here for performance. There are three main ways to identify the significant requirement or the architectural driver. The first one is the architecture requirement document, or the requirement document. In many projects and some big projects, the team might start with having appointing requirement engineers, or one or more, and these requirement engineers, they will communicate with the customer to get their requirement, and they will put that in a document. And the architect here can go through this document and identify the main architecture, the main requirement that she needs to specify the component of the architecture, the relationship between these components, and how actually the constraints among these components, the principles also for designing the architecture. We're not going to delve much into requirement document, but this is a major one of the techniques to get the requirement for the architecture. The second one is interviewing the stakeholders. So in general, even if you have a requirement document, the architect would go to the stakeholders to talk to them, to interview them, to identify the architectural driver. He would have his own way in order to identify this architectural driver. So there are simple things for that. As an architecture requirement engineers, they might say the system or the submission needs to be performant. But for the architecture, for the architect, that information is not sufficient. It needs how long would it take for a submission. How long would the customer tolerate for the submission to go through the full process? So they need to for example, to quantify the architecture requirements so it is possible to test these requirements. They need also to understand the business goals. What is the business? What is the goal of the company by doing the development? Because understanding the business goals allows already to know to have a constraint of time and budget to use that in the constraint of time and budget. So a business goal here, let's say, for example, we take the example of the websites for searching for a ticket, flight ticket, airline ticket. So those websites. So the goal here of the business is we want to produce to give the customer the opportunity to scan all possible airlines and provide them with the cheapest flight or flights with less connection. So based on criteria that the customer would say satisfy. So that is the business goal. Now for the architect, I know that I need to communicate with the different web services of the different airlines, and I need to query these things. So those are going to help me. In the requirement document, they would specify those are the text, the boxes in the user interface. This is how things would work. But it is important for me as a business, as an architect, to know what are the business goals, because those will help in the design of the architecture in a correct way. So when we interview the stakeholder, we do not use a formal representation like unified modeling language, but we use diagrams like this. So you have box and arrow diagrams, where you could have here, for example, and we write this, we put this in a whiteboard, and we talk with the customer about the constraints for the architecture, the decision that we would make, and their requirement at high level. So we see here in this diagram that the architect decided that they're going to use a browser to access the application. Will be a web application. They need the 3 layers here, and this web application is going to communicate with the database server, which is an Oracle data, which is going to use here the products and the orders databases. So based on this requirement, also we could see that the architect decided, in collaboration with the stakeholder, decided to use the Windows authentication to access the database. So they made here a set of also decision, like the protocol to use for communicating between the web server and the database server. So we said that the main part of the architecture are the component and the relationship between these components. What is a component? A component is a piece of software offering a predefined service and is able to communicate with other components. So when we talk here predefined service, it is already not a precise term. A service could be small, which offer one function, and it could be big. And that decision comes, how big it is, that decision comes to the architecture itself. In collaboration with the stakeholder, they need to come to an agreement of what are the services that they need. As I said, the diagrams don't need to be in a formal way, and we can see here this is an example of a diagram that represents an architecture for a smart home. And in this diagram, this is a non-technical diagram, obviously, because we are talking to the business. We are not talking only to the developers who are technical guys, but we are talking to the customer. We are talking to the investor. We are talking to different other people. And you can see here in this diagram that the architect represents the hardware, which has light, PAR, temperature, humidity, AC, unit central, the camera on the lower level, including also the network layer. Then they have the driver on the second layer. Then they have the sensor, so the light sensor, the motion sensor that are going to use those hardwares. And they have the network stack from the other side that allows to communicate these sensors and controller. Then they have the sensor framework, and this sensor framework is going to communicate with the sensors, and the controller manager, which is going to communicate with the AC controller and camera controller. So for the sensor, the sensor framework only reads the data from the sensor, asks for data and gets the data. For the controller, no, it is possible to change the value on these devices. For example, if you have the AC controller, you might increase the temperature, reduce the increase or reduce the temperature. For the camera, you might turn the camera and so on. So, and you can see here on the top that they put here kind of use cases where we have smart thermostat, temper detection, and motion detection. Those are user kind of functionality, which the architecture here put them because this is in a brainstorming session, they put them in this diagram. They should not be a part of a component diagram, but they are part of the brainstorming session. Another diagram here, this is the block diagram where we can see again here that we have the signing, authentication, authorization, monitoring, log trace, exception management, configuration. Those are components on the two sides, the component that they could be used by the different other component, the component on the different layers. So we can see here on the top layer that we have a rich UI, we have a web UI, we have controls, we have on the lower level service interface, then we have activity, business rules, human workflow and workflow until we get to the basic here, a set of system that we use, that this architecture use. So this is another representation or diagram that represents what is the architecture of the system and how actually the different components, they would visually interact between each other. Here we can see only the layer, obviously, but we do not see who communicates with what. But the one on the left, on the right, the component on the left and component on the right, they are available. Their features are available, functionality are available for the component that are in those six layers. So we said the architecture is an abstract model of software, and we showed how actually what are the component of the software, whether it was in this diagram or it was in this diagram, we talked about what is a component, right? So, and we said that there is a relationship between these components and so these components, they can interact. So also the architecture is, again here, the first design decision, the first design artifact where the system quality attributes are addressed, right? We're gonna talk about these. So there was a serious question that you might have. How do we get these components? So there are different strategy here for getting the component. One is to use functional decomposition, where we get the different functionality that we want for to develop a software, and then we decompose the software. We take, for example, SSH, which is a tool that you would use to access a remote machine. And I am going to think about what are the functionality that I have that I need there. The first one is authenticate, right? Where I could give username and password, and then from the other side, the server is going to authenticate me, is going to say, yes, this person, this credential, the owner of this credential is allowed to access the resource. And since this is SSH, SSH application, it implies that I can execute command, I can run command on the remote server. Let's say here, for example, if you used virtual machine and you access the remote virtual machine, with SSH, you could, for example, list the content of a directory, or you could install a new software, or you could run a new software. So running new software or executing a command, the command needs to be on the server. But sending the user interface or sending a command or specifying the command needs to be on the client interface. I can write the command on my laptop, but the remote server needs to execute that command. And that command, for example, to list the directory, is not the directory on my local machine, but in the directory on the remote server that I'm connected to. So I would specify all the functionality for my application. Then I would decompose these, which one should go to the client, which one should go to the server, which one should go to, let's say, a remote server, and so on. Another approach is to model the real world object. And the famous here example that you have with the account, example real world for banking system, where you have a user and you have a bank and you have an account, and then you could represent the software using a real world object. What are the objects that interact in the system, and that helps you to identify the architecture later on, to identify the component. We could also group the functionality based on any logic that we might see appropriate, right? So the basic thing here for component is to allocate the responsibility. and to identify the main functionality of the software and decide how these functions are allocated to non-runtime and runtime. When I talk about runtime here is that you have a process that you executed. When I talk about runtime here, I talk about package where you have a set of models or a set of classes there. So non-runtime, this is from development perspective. I have a package there. And runtime, this is a process that we can execute. So this is how we can get high level, how we can get the component. So let's take an example here. And the example, assume that you are asked to design a home security system. And this security system uses camera and motion sensors to detect movement and distress button to send alerts to a central system. And we want to have a sketch. So this is basically a home security system. So in this home security system, we want to have a camera, we want to have a motion sensors, and we want to use that information in order to detect that there is movement and send alerts to, and also we use distress button and send alert to a central system. So the central system can view the content of the house, for example, or of the business. And if there is anything that is dangerous, there is an intruder, then we need to make an alert. So this is unified modeling language diagram, component diagram for the system. And here, do not take these are examples of that you need to use unified modeling language and architecture, because if you have for technical at the technical level, it is better to use a formal semi-formal language like unified modeling language. But at the business layer and talking to the customer, it is better to write sketches. So a component, but this diagram could help us to see exactly what are the components. We see that we have a component sensor, we have a component camera, and we have a home device that is a node. And in this node, we have a set of component, set alert on and off, collect sensing, collect stream. We have also make alerts, detect infringement, and send alerts. We have from the other side server application, store images, assess dangerous places, store structured data, and so on. We have three databases. So we have here basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 component. You see that I got only the component are the one that they have shape, those rectangle shape with the small rectangles on the sides. So those are the components, and in this context, they are 15. So a regular architecture component diagram for when we talk about architecture at the business level with the customers, with project manager, would be represented this way. So you have the box and arrow diagrams. So it is it enough to know the component. So in the component in the architecture, we have the element, we have the relationship of these elements. But basically that representation does not, for example, might show the decomposition of the system. It could show the classes, it could show the layers where we have the model here relationship, but it cannot show that we have concurrency where we can, for example, in the previous one, can we run, for example, the star image? Can we have several instances of the star image? If the server, we're going to deploy it on the cloud, can we run several instances of assess dangerous places? So that information, we would, as an architect, at some point, we have to identify that and represent it using, for example, concurrency diagram. We could represent things using what are the processes. We could identify the processes. We could identify the data shared between the different processes. The allocation classes of diagram, we would see how we are assigning the work. So we have different packages and different component, and there are some developers that like the backend, some developers they like to work on drivers, some developers they like on front end. So different developers they have skills to work in different parts. And when you design the architecture, you might also use the some kind of an allocation diagram where you show what is the assignment of the different components to different people. We would also allocate the component to the deployment, to the different nodes, or also to the implementation. So far we said that the architecture is an abstract model, and this is a set of diagrams that with the aim that we implement these diagrams into a software. And the architecture defines the major component and the relationship between these components, which are relationship and the interaction. But also we said that architecture is the first document, design artifact, where systems architecture systems quality attributes are addressed. And when we talk here about quality attributes, I talk about here are the factors that affect the runtime behavior of the system. They affect the runtime behavior, they affect the system design, and they affect also the user experience. So quality attributes, they represent area of concern that have the potential for the potential for application-wide impact. So when we talk about cross layers and tiers here are the nodes for the deployment. So the common area are the availability, interoperability, modifiability, performance, security, testability, usability. So these are the quality attributes. So if we're going to have a requirement on the availability, then that requirement might concern one component or a set of components or architecture. But at the end of the day, it's going to impact the user experience. The same applies for interoperability, for modifiability. Modifiability, for example, will impact the easiness for the developers to change the software. So this does not concern the user, but it concerns the extensibility of the software. We have also the performance requirement, the security requirement, the stability, usability are also impacted. As an architect, so as requirement engineers, it might be sufficient to say that the submission needs to be quick. And term quick might be the common used term. But for an architect, we need to quantify what is that quick. And we take here, and to do that, we need to represent the requirement using a scenario. And in this scenario, we have to specify basically 6 items. So we specify what is the stimulus, what is the event that we care about. And here, for example, this is the regular application. Who is going to make that event happen? And here, this is the stimulus source, and here it is the user. What is the response? What is going to happen when we get this event? We're going to save the application, we're going to process the payment, and we're going to return a confirmation to the user. So this are the sequence of main activity that needs to happen in the system in order to have that, to get the details. It is possible that we have here process payment, whether this is a payment by check or whether this payment by credit card, payment through PayPal, and so on. This information, we need to identify them. Will be lower level design, lower level in the architecture. So the response measure, for example, is less than 5 seconds. As an architect, we have to figure out ways in the architecture such that we could guarantee for the customer that they're going to get something around 5 seconds so they have a good experience. They are not going to wait let's say 2 minutes or 3 minutes. The environment here, should be on the normal and overload condition. Even if we have 1,000 requests at the same time, we want to give the user the experience of having only 5 seconds for all the process to happen. The artifacts here that we would consider include the submission, the payment, the save file, and the save database. So these are the components that should be considered when we try to address this requirement. So how actually can we address these quality attributes? So let's take here for a case of performance, and the goal is to generate a response to an event arriving at the system within a given time, like the one that we discussed so far. So we need here to use some tactics or strategy or pattern in the technical terms, or architecture styles also in the technical terms, which implies a way on how to organize the component of the system in order to address these requirements. And one thing is, for example, we increase the resources here. We have more server to be available to process the requirement. We maintain copy of the computation. We are not going to duplicate the database and the computation, everything, but we are going to copy only some parts of some of the computation, some of the software. Or we might have to maintain multiple copy of the database itself because we know that we are wasting time on the database. It doesn't matter. So we would have only 2 server, but we could potentially have 3 server to write the data to the database that could be synchronized because we spend more time into writing to the database. This is writing to the database is writing on the hard drive, which takes time. It's an auxiliary driver. So good. So we got now some understanding of what is an architecture. We used to some diagrams, but why do we need this for? So the first thing is we would need the architecture for a proposal. So I said we need the architecture for the proposal. Recall that in order to convince your customer that you can do the job, and you need to provide them with the solution. And the solution would be in general the architecture. So each software should solve a problem, and the solution lies in the architecture of the software. In order for actually the stakeholder need to agree on the vision supported by the architecture. So if you have a design at the high level, everybody needs to agree on that they're going to provide everything that is needed to do that implementation. It helps to believe that the solution can be achieved with a predictable cost and schedule. Now, this is the first use of the architecture. At the proposal level, you can use it to convince the customer that you could achieve the goals to goals of the project and have them agree with you on what is your plan, how actually going to solve it. The architecture could be used also in the estimation, project estimation. And here, the model could be used in the breakdown structure. In the breakdown structure, we would decompose the system on small components such that we can estimate the time that it takes to develop each of these components. At the beginning here, we have project XYZ. Then we would think about this is the backend, this is the front end, this is the driver. Then the front end, we have work package 1.1, work package 1.2. Then in the server, we have 2 components, subpart 1, subpart 2. The first component, we have, let's say, 3 work packages, and the subpart 2, we have 2 work packages. This representation we call the breakdown structure. And it is used for project estimation, as I said, because it allows to go to a specific small details. And when we have small details, we could have an estimation, and then we could make the summation up to the project when we have an estimation for the project. The architecture could be used also for the project risk. So recall that quality attributes are the factor that affect the runtime behavior, the system design, and the user experience. So this runtime behavior, this system design, and those user experience could be impacted by choices on the technology or choices that we make in the technology. So what we care on at the architecture level is about the technical risks, which are related in general to the architecture. So this risk, they could be related to the choices of the technology. If, let's say, you decided to use Node.js for your software, or if you decided to use other support to develop backend, then there are potentially risks here. For example, if you work with Node.js, there might be security risks there, which are related to the system. And it's possible that the customer cannot deploy that software because of those specific risks. We have also the risks related to the satisfaction of quality attributes, whether you could satisfy the performance requirement or the security requirement that the customer specified. You might design a solution here, but it's possible that they will be challenging. And the project success is often dependent upon the architecture approach. As I said, half of the projects, they fail when we talk about failure, and the cause is weaknesses on the architecture. So things, they don't work well. So the last question that we are going to ask, or basically the last question that we're going to ask now in this lecture is, are there conflicts between project manager and architect? Where things would work, where things they could not work. And this is now here is based on experience, and this is not a study where we identified that there was conflicts between both, but this is the common sense. So the project manager and the architect, they have different concerns. The developers also, they have different concerns. The customer, they have different concerns, right? We've seen when we talk about stakeholder, when I have that slide of stakeholder, that each they have their own questions, and those questions, they represent their concerns. But basically, the project manager here, they want to have to balance cost, time, and quality. And they want to have an efficient, and here with code, an efficient architecture, because this is, we cannot quantify it, we cannot measure it. But we would say that this is efficient or not. The architect, they want to have solution that addresses the functional and non-functional requirement. They want the solution to address these requirements, and they want also that it is possible to extend this architecture in an easy way. So potential here, for example, of conflict, that the project manager, they are often resistant to new technology and idea. This is a risk. Using new technology is a risk for them. And based on personally my experience as project manager or the project manager, they want to avoid these risks, because the risk implies at some point that you might have to redo things. If you fail, you have to redo things. It might not be a total failure, but you have to redo things in different way. And if you redo, then you lose a lot of money, right? So if you spend 2 months or 3 months developing something, then at some point you find that does not work or does not address the requirement that you need, then you have to do that rework, and those few months are lost. The architect from the other side, they would see new, for example, technology as there is an opportunity here, or new idea that there are opportunity here. There is a new framework, and it's possible that this framework potentially, because they do some prototyping, and this framework seems to allow us to gain some time in developing things. So they are kind of more optimistic than the project manager, and where this is where we get this conflict. So we finished the main knowledge that I want to give in this lecture. And here for the self-check, what is software architecture? So try to answer those questions yourself. And how can software architecture be useful for managing proposal, managing project? We talked here about the use for proposal. We talked about time estimation. We talked about risks. There are potentially others, but at least those I brought you here from are the common things that I've seen myself in project that we worked on. Are there conflict between software architecture, software architecture and project management? The concerns are different. The conflict, there would be no conflict because all need to go to the same goals. But the software architect is more optimistic than the project manager when it comes, especially, for example, to technology. I finished this, so thank you for this lecture. And you might here discuss the content of the lecture, each of the lecture on Piazza, and I will answer this question. The next lecture would be, now we're going to get to more to the meat, and we're going to talk about the time and cost planning. Thank you. Bye.